Hello everyone, welcome back to CSE Core Concepts in the series of data structures, precisely talking about graphs, nonlinear data structure. Now here we are going to discuss in this video about spanning tree and a very important and interesting algorithm called as the Kruskal'S algorithm, which will help us to find out the minimum cost of a spanning tree. Now, first of all, let us see what is a spanning tree. First, a spanning tree is an undirected tree. Okay, so it is a undirected graph, or you can say tree. It consists of only those edges which are necessary to connect all the nodes in the original graph. You don't have extra edges. See, sometimes we have seen that a graph contains like one node to three nodes. It is connected to multiple nodes, right? But here, in case of a spanning tree, we will be eliminating the multiple nodes and we are going to figure out only those single nodes. Let's say you have you are at a source A and you want to reach to a destination B, right? Now there are multiple paths, five routes are there to reach to destination B. Now that is a graph, right? There are the different ways by which node A and B are connected. But if I want to go by a spanning tree, I will find out the minimum, the cost of the path. Okay, which path will give me the minimum cost, right? So that is what is a spanning tree. So for any pair of nodes, there will exist only one path. So I will find out which path will give me the minimum cost and rest all the paths I am going to eliminate. Okay, and I will add any edge to my path only if it does not form a cycle. So what is not will to be added to the spanning tree is that it should not form a cycle, right? And cost of a spanning tree will be of a weighted graph. Now, when you are going to find out the cost, obviously the graph has to be a weighted graph. The weights which are on the edges represent the cost of that path, right? Will be the sum of all the weights. So let us look at a tree, very interesting graph, right? So now here you can see from node 1 or node 0, let's consider two paths are being originated, 1 and 2. Okay, 0 to 2 cost is 2, 0 to 1 the cost is 5. Understood? So this way multiple paths can be there. So if we want to make a spanning tree, we are going to eliminate all the redundant paths or the paths which are giving us the higher cost. So basically, we are going to start with the interesting algorithm called as the Kruskal'S algorithm, which is a very greedy algorithm. What do we mean by a greedy algorithm? That it will make locally optimal choices with the hope that I will find a global optimum solution. So locally it will find out, okay, at first step it will try to find out the best choice. It will with a hope that if I make small best choices at every step, I will get a best answer at a global, like at the end I will get the best answer. So at every step here is important. So at every step we are going to find out the best answer with the hope that the final answer which we will get will be the best. And here what we will do is whatever graph is been given, now here in case we will get a undirected graph but a weighted graph. Understood? Because that weights are nothing but the cost among the nodes. So we are going to get a weighted graph. So we are going to arrange all the nodes in the order of the weights from smaller to higher. And at each step, we will go on adding the edge only if it does not form a cycle. So let us see with the help of a very interesting example. So with reference to the graph which I considered here, so how many nodes are there here? There are 7 nodes, 0, 1, 2, 3, 4, 5, 6, right? 7 nodes are there. And there are multiple paths from one node to another and each of them are carrying some weights. So the minimum weight which I can see here is 2, that is from 0 to 2 and 1 to 2. Then the next weight is in the ascending order if I go, the next weight is from 0 to 1, that is 5. Then it's 1, 2, 3, it's 6. So in this order of weights I have arranged this. Okay, so 0 to 2 is 2, 1 to 2 is having weights 2, 0 to 1 will have weight 5 and so on. Okay, now we are going to pick up one edge, okay, and we will add it to our spanning tree only if it does not form a cycle. Let me explain you how. Let us first pick up the first edge 0 to 2. Now since nothing is there, it is the initial state. So obviously I am going to put this. So 0 to 2 will be added to my spanning tree. No problem in that. Next edge is what? So it will be added. Fine. Next edge is 1 to 2. Okay. So 1 to 2, will it form a cycle? No. So I will add 1 to 2. Now 0 to 1, it is having weight 5. Now if you see 0 to 1, if I add this edge 0 to 1, what will happen? It will form a cycle, right? 0 to 2, 2 to 1, 1 to 0. It will form a cycle. And what did I tell you? In a spanning tree, we do not require a cycle. So we are not going to add this edge. Okay. Next, go to 1, 2, 3. 1, 2, 3. 1, 2, 3 if I am adding. Is it forming a cycle? No. Okay. So it is not forming a cycle. Fine. So the weight is 6. It has been added. 2 to 3. Now see again. If I add the 2 and second and third note, will it form a cycle? Yes. 0 to 1, 1 to 3, 3 to 2. It will form a cycle. So I am not going to add it. Fine. Now go to 2 to 5. Okay, 2 to 5 can be added having weight 10. It does not form a cycle. 4 to 6. 4 to 6 is fine with reference to that graph. It does not having any cycle. 4 to 5. Yes, 4 to 5 can be added because still no cycle is being formed. 3 to 6. Yeah. Now what about 3 to 6? It cannot be because if I add 3 to 6, you can see what is the connection? See, 4 to 6, 6 to 3, 3 to 1, 1 to 2, 2 to 5, 5 to 4. Again, it is becoming a cycle. Can you see? What did I say? If I add 6 to 3. Okay. So 6 to 3, 3 to 1, 1 to 2, 2 to 5, 5 to 4, 4 to 6, 6 to 3. So it will form a cycle. So I am not going to add 3 to 6. Fine. 5 to 6. Let's see. 5 to 6, again if I add 5 and 6, 5, 4, 6 will become a cycle. It will not be added. 1 to 4. 1 to 4 of course never. Never why 1 to 4? Because 1 to 4, 4 to 5, 5 to 2, 2 to 1, 1 to 4. Again they will form a cycle. So these nodes are not yet to be added. Understood everyone? So it will form a cycle. So we will remove it. Now to find out the cost. Now one thing could you see from this list that there is only one path between 1 to 3, 0 to 2, 1 to 2, 2 to 5. That between any pair of node there exists only one path. Which path? Which was the minimum. And secondly, there is no cycle formation. This is a spanning tree. Okay. So if I want to find out the cost of this spanning tree, so let us add all the weights starting from 0 to 2 is 2, then 1 to 2 is 2, 1 to 3 is 6, then 4 to 6 is, 2 to 5 is 10, then 4 to 6 is 11, and 4 to 5 is 12. So it adds up to 43. Okay. So this is a very, very interesting approach of finding the minimum cost of the path. That is the Kruskal'S algorithm. So in my next video, I am going to discuss about another way by which we can find out the spanning tree. That is a Prim's algorithm. So if you like this video, please press the like button and don't forget to share and subscribe to CSE Core Concepts. Thank you.